All right, so now we're gonna go ahead and talk about triangular prisms. And so when working on triangular prisms, again, just want to remind you that a prism, not just rectangle. There's other shapes besides rectangular prisms that are prism, obviously. Uh, if your base is a rectangle, it's called a rectangular prism. If your base are triangles, then it's called a triangular prism. A good example that I was showing you guys was this binder right here. So this binder has triangular parallel bases, and they're connected by rectangles. And that's the same thing here. Okay, so again, you can see how we have two triangles that are the same and parallel, and they are connected by rectangles. All right. Again, it's kind of hard to visualize it. I'm gonna go ahead and get my other computer really quick, and again, since it stands out a little bit more because it's darker, show you what I mean here. So again, I don't know if you see here the triangle. Oops, there you go. Right there. So that white triangle created right here. So that base, and then this other triangle right here, they're pretty much the same triangle. Okay, and these are your bases because they're parallel to each other, and they're connected by rectangles. Okay, so again, that's what makes it a prism, the fact that it's connected by a rectangle. So anyways, the formula is identical. As long as it's a prism, volume will still be the area of the base times the height. But this time you cannot go and say that it's length times width times height, because your base is no longer a rectangle. Now it's a triangle. So again, triangular prisms will have a base that happens to be a triangle. So when you're trying to find big B, where big B stands for area of the base, since it's a triangle, you're going to have to do base times height divided by 2. Do not confuse this height with that height. They're obviously different. So if you want to use subscripts, right, H1, H2, or things like that to help you differentiate, go for it. But obviously, in your base, that's where you're going to find your base, and that's where you're going to find your height. Sometimes there, sometimes on the outside, right? But the whole point is base and height, when you're looking for the area of the base, will be on the actual figure of your base. Let's look at an example. So here we have, again, a triangular prism. Our base, we can see that it's a triangle. It's an isosceles triangle with the sides of 5 here and this bottom part of 6. Now we need to find the area, and again, area is base times height divided by 2. We don't know the current height, but if you saw that video, if you recall, or you just remember how to go about this, we can draw our own height. This is going to be my height. Now, it was isosceles, I cut it right down the middle. Half of 6 is 3. So this is an embedded problem where in order to solve my height, I have to do Pythagorean theorem. Okay, so again, it helps, guys, to practice. That way you don't have to, come and redraw this stuff all over again. Yes, I'm going to be working with this, but I'm not even going to bother drawing it again. So again, to find the height, I'm just going to focus on this little piece right here. I know my hypotenuse, and I'm going to subtract. So to find my height, it's the square root of 5 squared minus 3 squared. And I know that I'm going to get 4 in this case. So the height of the triangle here is 4. So when I'm looking for the area of the triangle, it's going to be 6 times 4 divided by 2. So that's 24 divided by 2, that's 12. The area of the triangle is 12. The area of the base is 12. So I can say that big B is 12. Next up, we need to find the height of the overall base. Now the height of the overall base is basically going to be found by the distance between the two bases. So one thing you could do is just, you find your bases and find a line connecting them. Boom, that's your height. My height overall of my prism is 10. And so I wanted to find the volume. Volume is just big B, which is big B times H. Big B is 12. My height is 10. And that's it. It would just be 12 times 10, and I get 120. That easy, guys. Okay, the thing about triangular prisms is odds are you are going to have to find something, right? Find the height or something. Maybe you'll do Pythagorean theorem. Look for that. Here's the last example I want to talk about here. This one's an easy one. Again, I would like for you to identify the base. Draw it on a piece of paper, sorry, and identify the base. So yeah, these are our bases. I would like for you now to find the area of this base. I would like to remind you that in our base, we have this nice triangle right here, where we know this is 4, this is 5, and my hypotenuse is 6.4. So something I didn't mention, and I should mention right now, is your bases are parallel and congruent. So this is 5, this is 5. Just like this is 4, you would expect this to be 4. Please remember that. Your bases in prisms are parallel and congruent. Again, you can see that in this box. This base is congruent to this base, and they're parallel. Find me the area, guys. Okay, good. You had some time to find the area. Again, I expect you guys to put pause and then just find it. So again, this is a triangle. So to calculate the area of the triangle, it's base times height divided by 2. My base is 5. My height is 4. So the area of the triangle is 10. So I can honestly say that big B is 10. The area of the base is 10. For those of you guys that were thinking of using 6.4, please remember that if you just identify where the 90 is and trace the two sides that make it, that's your base and your height. Now as for the distance, the height, the distance between the two parallel bases, it's any one of these lines. And right now, you know this one, so H is 8. And just like that, volume is just 10 times 8. In this case, volume is just 80. And that's it, guys. That's it.